So in this video, we're going to be dealing with inverse functions. So let's say that I had the function y is equal to 36 over x. This is an inverse function, and the reason why is because as x goes up, y tends to go down. And the reason this is because the denominator is getting larger and larger, and as the denominator gets larger and larger, the numerator is not going to change. It's a constant. So the y value tends to go down. And so if we were to look at another property of this function, if we look at y times x, so we multiply by x on both sides, this is going to be equal to 36. So any x value is multiplied by the y value is always going to be equal to 36. So if we had an inverse function, and the inverse function has a bunch of x values and y values, when you multiply the x value that corresponds with the y value, so x comma y, and we multiply those two together, you're always going to get the number 36 for this function. Let me give you an example. So let's say that we had a table, and this table here is for this function right here. Y equals 36 over x. So x, y. If x is, say, 1, y is going to be 36. If x is 2, y is going to be 18. If x is 3, y is going to be 12. If x is 4, y is going to be 9. And, of course, we can go on like that, of course. And let's just do one more. Let's do this. If x is 9, y is going to be 4. So let's look at this. Let's look at what happens with this. So x is going up, right? X is going up. But y, as you see, is actually going down. So y is going down as we go in this direction. So y values decrease. X values increase. If we went the other way around, then as y values go up, so in this direction, x values in the same direction are decreasing in this direction. So for this one, x values decrease as y values increase. So that's a special property. Now another property is if you just multiply these two together, you should always get the constant k. So multiply these two together, you get 36. Let me do that in a different color. So multiply these two together, you get 36. Multiply these two together, you get 36. Multiply these two together, you get 36. These two together, you get 36. 36. So for all values of x that are in the domain, we're going to have the x values and y values multiplied together are always going to give the value k. So this function is actually in the form y equals k over x. So this is the inverse function form. Inverse function. Now another special thing that you need to think about when you look at this is that x equals 0 is not a part of the domain. So x cannot be equal to 0. So if you were to think about the x times y property, right? X times y is always equal to k. You might be thinking, well, if k is some value, then how is x times y going to be equal to that k if x is 0? Because then it's just going to be 0, which is not going to be equal to 36 in this case. Well, x cannot be equal to 0 because that's not part of the domain, so we don't worry about that case. We don't worry about that scenario. So x is equal to 0 is not a part of the domain. Y equals k over x. So some applications of this kind of a function is, say for example, you are filling up a pool, right? You're filling up a pool. So this is a pool. Draw that in white. So say this is a pool, and you're filling it up with water with some hose here. And as you fill the pool with water, the water level is going to increase. The water level is going to increase. However, what's going to decrease? Well, the the remaining space, the space that's empty, right? The empty space essentially is decreasing. So the empty space is going down. So this is the empty space in white, and that's just going to be going down. So as one is increasing, the other is decreasing. So if we relate the two quantities, volume and, well, not volume, the water level and empty space, then we would get a function that is an inverse function. And there's many inverse functions out there. Think about it. Think about many inverse functions in your mind and try to think about how their functions would be expressed. So I hope you found this video helpful, and think more about inverse functions because they're very interesting.